Alright, this is where we left off in the previous video. This was the last slide of the previous video. So I'm just going to start here. We're going to talk about pH again. pH is just a way of describing with a number how acidic a liquid is. And it's a little bit confusing because the smaller the pH number, it means your liquid is more acidic. And the bigger the pH number, that means your liquid is less acidic. And another way of saying less acidic is more basic. So for most liquids that are mostly made of water, that's what aqueous means here. For most water-based liquids, the pH usually ranges somewhere between 0 and 14. So if you plug information into the pH equation, which is -1 times the logarithm of the H3O plus concentration in units of molarity, the pH will be somewhere in between 0 and 14. A lot of times teachers will tell you that the pH has to be between 0 and 14. That's not true at all. You can have pHs that are less than 0. You can have pHs that are more than 14. It's just not easy to get there, but you can certainly do it. In this case, if you had a liquid with a pH of 0, that would be very acidic because that's a pretty low number. And if you had a pH of 14, that would be very basic. Halfway in between 0 and 14 is the number 7, and a pH of 7 is usually considered to be neutral as far as acids and bases are concerned. What that means is the amount of H3O plus, which is chemistry shorthand for acid, is equal to the amount of OH minus, which is chemistry shorthand for base. So at pH 7, the amount of acid and base running around in your liquid are equal to each other. So there's acid isn't winning and base is not winning either, and so you say that it's a neutral pH. And a lot of times the way that teachers explain what neutral is they say you can't go, your liquid has to have a pH somewhere between 0 and 14. Halfway between 0 and 14 is 7, so 7 is neutral. That's not really the reason why 7 is neutral, but 7 is usually very close to neutral, and that's sort of the lie that we tell students is that halfway in between is 7, so that must be neutral. There are other reasons for why pH 7 is neutral or very close to neutral, but we're not going to go into them. So what I want you to know is that if you have a liquid and the pH is less than 7, then you say your liquid is acidic. If you have a liquid and the pH of the liquid is more than 7, you say that your liquid is basic. And if you have a liquid and the pH equals 7, then you say that your liquid is neutral with respect to pH. So if I said I have two liquids, A and B, and the liquid in A has a pH of 6, and the liquid of B has a pH of 9, and I said which one is acidic, you would say it's A. Solution B would be basic. I could give you a different situation. I could say you have two test tubes, A and B. The liquid in A has a pH of 6, liquid of B has a pH of 5, and I could say which liquid is more acidic. You would say it's B, because this pH of 5 is lower than a pH of 6. Usually when people bring up pH, they trot out a number line, so I'm going to trot out a number line, and you can see my number line goes from 0 to 14. 7 is in the middle. You'll remember that 7 is pH neutral. If you have a liquid and the pH is going more and more to the left here, the pH is getting smaller and smaller, that means your liquid is getting more and more acidic. If you have a liquid and the pH number is getting higher and higher, your liquid is getting more basic. And what that means is if you're traveling more to the left, the concentration of H3O plus is going up and up and up as you go to the left. And if you're traveling to the right, the concentration of OH minus is going up and up and up as you go to the right. I'm just going to put some reference liquids up here. Pure water has a pH of 7, at least under the conditions that we are usually accustomed to. So pure water is usually pH neutral. Blood, so human blood, has a pH that is slightly basic. I think it's around, the pH of human blood is somewhere around pH 7.3, but don't quote me on that because I don't know much anatomy and physiology. But I know it is slightly basic. It's just over 7. Stomach acid has a high acid concentration, so the pH of stomach acid is often between pH of 1 and 2. 0.1 molar hydrochloric acid has a pH of 1. If you want to think about why that is, the pH equation is going to be -1 times the log of the acid concentration. And in our case, the acid concentration is 0.1, so the pH is going to be -1 times the logarithm of 0.1. And if you figure this part out, the logarithm of 0.1 is -1. -1 times -1 is +1. So the pH of 0.1 molar HCl is going to be +1, which is quite acidic. So what I want you to know, if I give you the pH of something, you should be able to tell me if it's acidic, basic, or neutral. Like I said, here's some pretend test tube with some watery liquid in it, and the pH is 10.3. Is it acidic, basic, or neutral? In this case, it's going to be basic because the pH, if the pH is greater than 7, you say your liquid is basic. If I give you the concentration of H3O plus in a liquid, you should be able to use the pH formula to figure out what the pH of your liquid is. So for example, I'll give you the pH formula, -1 times the log of the H3O plus concentration in molarity units. And if I said the concentration of H3O plus in your swimming pool is 6.2 times 10 to the -6 molar, what's the pH of your swimming pool water? You can pause the video and take a minute to figure that out. So if we do that, let's do it over here. The pH is going to be -1 times the logarithm of 6.2 times 10 to the -6. The logarithm of 6.2 times 10 to the -6 is about -5.2. And so -5.2 times -1 is equal to +5.2. And so the pH of your swimming pool would be 5.2. It would be slightly acidic. So you should be able to do that type of problem. And that is the end of this video on pH. 1 or 2 more videos and then we'll be done with this chapter.